This video will be about the probability of compound events. So when you're working on probability of compound events, you have more than one event. More than one thing is going on at once. It can be the same object. Maybe you're rolling a dice more than once or flipping a coin more than once, but each event is each time you flip the coin or each time you roll the dice. So independent events are events that do not influence each other. So that could be like rolling a dice. The first dice roll would not affect what's going to happen when you roll the dice a second time. Or like flipping a coin. The second coin flip does not affect the first coin flip. Or if, say you had like a bag of marbles and you had like 5 red, 10 blue marbles, and you pick a marble out, if you put the marble back in, your second pick would not be influenced by what happened the first time, because you put it back. It's the same bag of marbles once you replace the first one you picked. So when you have two events, they usually represent A and B is just, A is event 1, B is event 2. So the probability of A and B happening is their individual probabilities multiplied together. The probability of event 1, so probability of A, times the probability of event 2, so times probability of B. So let's do a couple examples. Let's say you roll a red dice and a blue dice. Find the probability you get an odd number on the red dice and a prime number on the blue dice. So when you're working through your probabilities, we need to know about the events we're working with. So when you roll the dice, there are 6 sides to the dice. So you could get a 1, 2, 3, 4, 5, or 6 on either dice roll. So that means on each dice roll you have a probability of 6, or a total possibility of 6 things happening. You could roll a 1, you could roll a 2, could roll a 3, could roll a 4, could roll a 5, could roll a 6. So 6 total choices on each of these. Remember, our goal is to find the probability of odd and prime. Odd on the first dice, prime on the second. But individually, we'd have probability of getting an odd number. Well, there's 6 total, so that's what the bottom of our fraction would be. Probability is always total on the bottom. So same thing for prime, there's 6 total. So we'd put 6 on the bottom. Now, odd numbers are 1, 3, and 5. So there's 3 odd numbers to choose from. That's the top of our fraction. Prime numbers are 2, 3, and 5. Prime numbers are numbers that only multiply by 1 and the number itself. So there's also 3 prime numbers to choose from. So now we take those individual probabilities. I'm going to reduce each of them first. 3 and 6 both divide by 3, so that would become 1 and 2, because we divided both of them by 3. Same thing over here, 1 and 2. So probability of odd and prime is the same thing as each one multiplied individually. Probability of odd times probability of prime, which would be 1/2 times 1/2, or 1/4. So let's look at another example. You have 15 tiles. There are 2 tiles with the letter A, 5 tiles with the letter B, and 8 tiles with the letter C. If you replace a tile after your first pick, find the probability, should be a T there, of picking the letter A and then the letter B. So probability of A and B. We need individually the probability of A, individually the probability of B. Let's see, we had 15 tiles total, so the bottom is the total, and there are 2 tiles with the letter A, so 2 out of 15. 15 tiles total for B, and there are 5 tiles for B. Now 2 out of 15 won't reduce, but 5 out of 15 will. Both of those divide by 5, which would give us 1/3. So probability of A and B is the same as multiplying the two probabilities together. So 2 over 15 times 1 over 3 would be 2 over 45. So a second option for two events is for the events to be dependent. The first event affects the outcome of the second event. So this time, if you had that same bag of marbles and you took one out for your first event but then didn't replace it, now you have less marbles to choose from for your second pick, so the second event was affected. So when that happens, probability of A then B is probability of A times the probability of B after A. So let's look at an example of this. Let's say you have 15 tiles, 4 with the letter A, 1 with the letter E, 3 with the letter I, 2 with the letter O, and 5 with the letter U. If you do not replace the tile after your first pick, find the probability you pick the letter I, then the letter E. So probability of I, then E. So we would need individually the probability of I itself, then the probability of E after you've picked I. So probability of I, there are 3 tiles with the letter I, and there were 15 tiles total. That can reduce. They both divide by 3, which would give us 1 out of 5. So then probability of E after you've picked an I. So if you've picked a tile and you don't replace it, now the total is 14. There are only 14 tiles left total, and there's only 1 with the letter E. So you have a 1 out of 14 chance of picking E. So probability of I then E, it was these two probabilities multiplied together. So 1 over 5 times 1 over 14 is 1 over 70. 5 times 14 is 70. So one last example where we're going to do both kinds of probability at once. A bag contains 6 white counters, 5 red counters, 4 green, 7 blue, and 2 black counters. So it didn't tell us the total, so first I'm just going to find the total. 6 plus 5 plus 4 plus 7 plus 2 is 24. So total is 24. What is the probability of choosing a green and then a white counter if you replace? And what's the probability of choosing a green and then a white if you do not replace? So we have a probability where we're replacing, and we have a probability with not replacing. And we want probability of green, then white, for both of them, but it's going to be a different answer because one we're replacing, one we are not. So individually, probability of picking a green. There are 24 tiles total, and there are 4 green. Both of those will divide by 2, but we want the biggest. They also divide by 4. So this will reduce to 1 over 6. So then we replace it, which means our total is still 24. So probability of getting white is still out of 24. And there are 6 white counters. Both of these will divide by 6. So we get 1 out of 4. So 1/6 times 1/4 is 1 over 24. So now I'm not replacing. The first probability would be the same. Probability of getting green is still 4 out of 24, which would still reduce to 1/6. But the probability of getting white will be different, because now you're not replacing, you only have 23 counters left. And when they use the word counter, that can be pretty much anything, like you could do a marble or like a little red coin or something. Doesn't matter, counter is just an object that's the same for all of them. So probability of white, there are still 6 white counters, but now it's out of 23 total options. This does not reduce. So we do 1/6 times 6 over 23. We can cross-cancel. Both of these 6's can cancel each other out since one's on top, one's on bottom. And that leaves us with an answer of 1 over 23. So with replacement, it's a 1 out of 24 chance. Without a replacement, it's a 1 out of 23 chance. So that concludes our discussion of compound probability.